Hello everyone, and welcome to the Simple Game Project Solutions lecture. We'll be finishing off Python Level 1 with this lecture, where we're going to be coding through the solutions for the game project. Let's get started. Okay, whenever we begin a project, it's always a good idea to map out the steps we need to take to actually complete the tasks. For one thing, I'm going to need to get the actual player guess. So that's one of the steps I need to do. The other thing I need to do is generate the computer code. That's the 3-digit number. Then I also want to generate the clues. So that's going to be comparing the guess to the computer code that I generate. And then what I want to do is actually have some sort of logic that runs the game. So we'll call this run game logic. Okay, let's get started with the simpler function of getting the guess. So what I'm going to do here is say def get underscore guess, and I won't take any actual parameters for this function. Instead, what I'm going to do is return the input of what is your guess. So let's actually here at the bottom where it says run game logic, test this out by saying get guess, and then I'm going to save this as some variable called x. And then let's say print x. I will save this and let's run this. So I will say python notes.py, hit enter, and I see I get function. So actually, whoops, forgot to call the function. And now let's run this. Okay, so it says, what is your guess? I'm going to input, let's say 1, 2, 3, hit enter, and it types 1, 2, 3 out. Now let's check to see what type that is. Going to save this, run this again. I'll put 1, 2, 3 as my guess, and it says it's a string. So I can see here that any input is a string. Now you can definitely work with a string and you can index off a string. So I could say something like x0 and then do stuff with it. But a string is also immutable, and I may want to play around with this object more. So I will cast it to a list after the input. Again, it's totally up to you. There's many ways you could have created this project, but I'll just do that for safekeeping. And now my getGuess function is complete. The next step is to generate some computer code. So this is the 3-digit number that the computer is going to generate. And I'm going to say generate code. And then let's do it this way. I'm going to create an object called digits, and I will use list comprehension to do it. Again, you could have just used a for loop here, but I will say string num for num in range 10. So here what I'm doing is I'm creating a list of every number from 0 to 9, and I'm going to cast it as a string. And then what I need to do is generate a code. So I will say this, shuffle this digit. So I'm going to shuffle the digits, then grab the first 3 after the shuffle. And this was given to you as a hint in the hint lecture. So I will say import random, and we'll talk about importing random and making your own modules later on. But this will allow you to say random.shuffle. We can pass in our digits list. And then when I grab the first 3, what I'm going to do here is say return digits, colon 3. So I've created digits, shuffled them, and then returned the first 3. So that should give me a random 3-digit code that is completely unique. So all the numbers are unique because I used range 0 to 9. Next, I want to generate the clues. And this is probably the harder part, but with a little bit of logic and control flow, we should be able to manage it. I'm going to create a function called, let's just call it generate clues. And it will take in the code that the computer did, and then the user guess. So the user is going to make some guess. So this again is going to take in a user guess and some code, and then compare the numbers in a loop, and it's going to create a list of clues according to the matching parameters. So first off, I'm going to say if the user guess is equal to the computer code, I'm just going to return code cracked, because if the guess is the same as the computer code, well, then we're all done here. So that's the very first thing I should check. Next, if that hasn't happened, I'm going to create a list, an empty list right now called clues, and I will keep adding to it as I go through the user guess. So something I can do here is use enumerate. And let me show you what enumerate actually does. I'm going to say for ind num in enumerate, and you don't have to use enumerate, but you can. Basically what it does is it allows you to, instead of having to do something like count equals 0, or to make this a more realistic example, ind is equal to 0, and then come in here and say something like ind is equal to ind plus 1. If I just want the actual index, I can use enumerate, which is going to enumerate starting at 0 for me. And then I'm going to put in the user guess. And then I will say if num is equal to code ind, I'm going to append match. So what does this actually mean? Well, I'm going to, with enumerate, go through the user guess, and using tuple unpacking, I'm unpacking two things: the actual index location and then the number itself. And I'm saying if the number is equal to the code index location, so remember I'm going through user guess, so I'm saying if the current number in user guess is equal to the number of the code at that same index location, then I know I have a match. So I will append the word match to my list of clues. Then I'm going to say elif num is in code. So what does that mean? Well, I know the num is somewhere in the code. Then I will say clues.append close. So I'm saying, hey, you didn't get a match, but you were pretty close. And pay attention to the ordering here. I'm saying if there's a match, then check that first. Then if the num is in the code, append close. I can't have this go in another order, so I can't check for close first. Otherwise, I would always skip over match. So pay attention to the ordering here. It's kind of important for the specific case. Otherwise, if I didn't actually have a match or a close, what I'm going to do is start off with another if statement where I say if clues is empty. So after going for the for loop, if the clues is empty, then all I'm going to do is return a list of a single item that says nope. And then I will say else return clues. So what does this actually mean? Well, let's break it down. And I'm going to zoom out a little bit so we can see the entire function while we break it down. Okay, first off, I just want to check if the user guess matches the code. If it does, I've cracked it and we're ready to go. Otherwise, what I'm going to do is define an empty list called clues. And then using this special enumerate function, I'm going to go through the index and numbers. Again, you could have done this without enumerate by just saying index equals 0 and then adding to index for every iteration of this for loop. But this is kind of just a convenience function. Then I will say if the number at the user guess is equal to the code at the specific index location, then I'm going to append the word match. Else if the num is in the code, then I append close. And note the order here, I have to check for the match first before I check if it's close or not. Then, if I go through this entire for loop and clues is still empty, meaning there was no match or there was no close, I'm going to return nope. Else, I'll just return clues. Next, it's time to add in some game logic. So let's show you how we can do this. I'm going to print something like welcome codebreaker, and then I will generate a secret code. So I will make some variable called secret code and set it equal to generate code. Remember, generate code returns the computer's code. So that's the secret code, and then I'm going to also say make some variable called clue report and set that equal to an empty list. And let's try to follow snake casing here. And then I want to keep asking this until the code is cracked. So while clue report is not equal to the string code cracked, and let's make sure that matches exactly up here. Okay, so while it's not this, here's what I'm going to do. I'm going to set my guess equal to get guess, close parentheses. And then what I want to do is say clue report is equal to generate clues of the user guess and the secret code. Then I'm going to print, here's the result of your guess, and actually say for clue, inside the clue report, print the clue. And this keeps going over and over and over again until I actually have a clue report that says code cracked. Because remember, generate clues returns this string code cracked once I've actually gotten the correct code. So let's run this and see if we can actually play a game. I'm going to say Python notes.py, hit enter. Looks like I have invalid syntax right now. So I say if clues equal to, whoops, that should be 2 equal signs. So let's check that. That's happening at line 29. Scroll back up, we'll say if clues double equal sign, save this. And you can always reference the course solution notes to get the actual correct code. Now I get python notes.py, perfect. Welcome Codebreaker, what is your guess? I'm going to guess 1, 2, 3, hit enter, and here's the result of your guess. It says match, match. So let's confirm this by typing something like 5, 6, 7. And we get close, so that's interesting, means one of the extra numbers is 1, 5, 6, or 7. So that means if I say 890, it should give me none, or nope. Perfect. So it looks like my game's working so far. So now it's just time of guessing. 3, 2, 6, 6, 3, 2, 6, 2, 3. All right, looks like the code was cracked with 6, 2, 3. Great. All right, so if you have any questions on how to do that project or what was going on, feel free to post to the Q&A forums and make sure you walk through the solutions code yourself. This is just one simple example of how you could have done this problem. There are many, many ways you could have done this project, and you could have added more to it. It's really up to you how far you want it to go, but again, if you have any questions, feel free to post to the Q&A forums. Thanks everyone, and I will see you at the next lecture.